So today we're going to talk about, hopefully it's cool, yeah, talk about edge devices as interactive personal assistants, unleashing the power of generative AI agents. It's a very, very long title. Hopefully this doesn't run long. I have a bunch of slides. I'm going to skip through some of them for the interest of time, but let's see how this goes. So if you didn't attend my presentation yesterday, and this is the first time we're meeting, my name's David. I've been fortunate to work in the AI and ML space kind of when it's been blowing up. I specifically work in like NLP, conversational AI, but I'm like an AI enthusiast. I love it. Previous to that, I was in the Cloud Native Computing Foundation working on all the projects related to Kubernetes, and also have a huge background in doing backup recovery solutions for a virtualized environment, specifically for like VMware vSphere. So for the agenda today, I'm going to do a brief review of generative AI. I'm sure there's a lot of generative AI talks here yesterday and today. I'm going to do a slight review. It's going to be a couple slides that I've condensed from my last presentation into this one, just to kind of level set and give everyone a background. And then we're going to talk about generative AI autonomous agents and how they're probably going to be the next new thing. So it might be a very newish topic to some people. And then we're going to do a Hey Google, Siri, Alexa design with in the context of doing IoT, in the context of IoT and edge devices. And then we're going to have a demo. Hopefully the demo gods are going to praise this and it works. I'm going to do it live. It's not going to be a recording, so it'll be kind of interesting. And then we'll have some time in for Q&A. So a review of generative AI and what it is. So if you didn't get a chance to catch my presentation yesterday, I linked it there. You can check out the slides. Hopefully it's recorded and it'll be posted somewhere. That'll be awesome. If it is, if it's not, you can at least look at the slides and review it. So I wanted to explain, okay, it's going to be recorded? Okay, cool. So why is everyone talking about chat-gpt? I think the reason why it got so popular is because it gives you human-like responses and interactions. And I think that's the biggest reason why it's kind of caught on. The interactions have been relevant. So you ask a question and it's a relevant, meaningful answer, right? A reply. It's not some gibberish. And then also the ease of use, right? I think what OpenAI did was really democratize AI. It made it super accessible. You can literally go on their webpage, click a button, sign in with Google, and just go. And it's pretty cool. I mean, I use it for all sorts of crazy things hey, I need a tweet for this blog post or whatever. Believe it or not, it saves a lot of time doing that kind of stuff. So how did they achieve this? So like I said, lifelike conversations in a chatbot form. And they also have APIs, but I think most people are not using the APIs. They're just using the UI interface to get to chat-gpt, but the interactions are so, perfect, quote unquote, that it's able to pass the bar exam. So based on an Illinois Tech white paper, which I've linked to right there. So it can pass the bar. And in my last presentation, I said that chat-gpt can hallucinate. It can come up with very, very plausible sounding alternative facts or things that are not true. So believable that you're like, oh yeah, sure, I'm going to repost it, and it's a complete fabrication. In this kind of context, there's actually a benefit. When it hallucinates, it's actually pretty creative, right? It can come up with stuff and do storytelling. It's actually kind of amazing when it hallucinates. And actually there's ways to make it so you can force it to hallucinate even more, which is even kind of more interesting and kind of cool. So under the hood of the car, it's all AI is driven basically using machine learning. And in machine learning, if I were to boil down what machine learning is, it's basically next token prediction. So I disassemble a whole paragraph into sentences. I disassemble that stuff into words. Those individual words are tokens. You assign values to them of how important they are, discard a, the, and, those kinds of words. And then start to build up to take the tokens. Now you have tokens for larger sentences and paragraphs, and then you make probabilistic associations between what that response is going to look like based on the value of that, what that looks like, that graph, right? So again, predictions so good that that AI seems like human. And there's an interesting article at the bottom. Humans were only able to predict that they were talking to an AI 60% of the time. And that's a very interesting number because you're not that far off from a coin flip, that you don't know 50-50 if you're talking to an AI or a bot, an AI or a human. Now, it varies by region, it varies by age, it varies by gender, it varies by all sorts of things. But it's just very interesting overall. It's about roughly a coin flip. And so we've trained these AIs to like understand conversation and be able to like communicate with humans in a very meaningful way. So if they're able to communicate, what happens if we let these generative AI models talk to themselves? And that's kind of like the basis of like this talk here. So generative AI autonomous agents, like what are they? So this is possibly going to be the next evolution of AI. So it's kind of emerging. It's very interesting. What are autonomous agents? So autonomous agents are effectively like agents that can talk to themselves in a way that they can create their own tasks. So you effectively give it like a starting prompt, like I want you to do this. And from there, it can break down like, hey, in order to achieve this goal, I need to break this thing down into these tasks. I'm going to start researching on my own and figuring out this thing, that thing, and so on. So in these, just like LLMs, these autonomous AI agents can be fully autonomous. They can be partially supervised. And there's also the capability for doing reinforcement training. And so like if you're not familiar with like reinforcement training, I have a Google webcam at home. It can actually track and identify people, animals, and all sorts of stuff. And it can actually do facial recognition. So it can say, David Von Thenen appeared in this video on the doorbell outside. If you've drilled down into that video, there's a thumbs up and a thumbs down that says, was David in this event? And that is reinforcement. When every time you click that, you're basically reinforcing Google Home to say, yes, that was David. So that's what reinforcement learning is. So these autonomous agents, going back, that was an interesting side step there, but these AI autonomous agents, they have memory, right? And that's the biggest, probably most important thing. There's one more huge one at the end, but they are able to store what they've learned into a database. And then the other one that's pretty significant is that they can do very long running tasks. So if you're looking at like Google, Siri, Alexa, you have one question, one answer. It's very transactional, right? In this case, it's like you give it a task to do and you let it run. And it could come back in an hour, it could come back in 5 minutes, it could come back in a week. So it's very interesting like what these things can do. I don't know if you remember, like, I'm kind of going off topic again a little bit, try to keep on time. I don't know if you remember there was a news article that said, you probably recognized or maybe missed it, that these autonomous AI agents are kind of been out there for a while. There was an article in the news saying that chat-gpt tricked a person to actually click the CAPTCHA using a TaskRabbit, paste a human to click the CAPTCHA so it can get past the, am I a human or a bot thing. That was an autonomous agent, right? So that's very interesting, like how these autonomous agents are able to figure out problems, use APIs, and even hire someone on TaskRabbit to click, like I am a human. So it's, Google the article, I think I have it at the bottom. It's very cool and interesting. So there's a lot of these agents out there. AutoGPT and BabyAGI were the first ones. At the time, there was about like roughly 10-ish. Now there's over 20, far more than 20. Some commercial, some open source. But you can see the list there and check it out yourself. So, like, what does the architecture look like? So I'm going to talk about one specific one because it has a very interesting play for Edge and IoT. It's called BabyAGI. It's one of the older ones. It's one of the first ones. It's still maintained-ish, but it's kind of interesting because of reasons we'll kind of get into at the end. This is the architecture. We're going to skip it and just go down to like what that architecture actually really means. So to do like what the high level process of an autonomous agent is you give it a task, you give it like a prompt, like what you want it to solve. And then you can also optionally give it like a list, like these are the points that I want you to hit on in order to solve your problem. It will take that task list and then expand on it, maybe add more tasks. It pulls the highest priority task off the queue. It solves the problem. It takes that information and it stores it into a vector database. Then it sees, it has optionally has the choice to make another task, like if that research decide, like there was something else that it needed to explore based on that research, it will add the task to the list again, reprioritize the list, and pull the next highest priority one over and over again until there are no more tasks, and then you have your answer. And that's kind of effectively how it works. So the interesting thing is that there's optimizations you can do because of the little nuances and differences from a normal large language model like chat-gpt. Large language models that are like running like super independent discretely, like transactional. One is that the memory prevents revisiting questions that it's already answered. So if it hits the same question again, it'll just return the result instead of spinning there forever, right? Especially if it's like much farther up in the tree where it's answered all these questions and it's got a, you're answering the question up top. If you already know the answer to that, you can skip everything underneath it. So there's like optimizations like that. There's also optimizations because all that stuff is stored in a database. You can alter the agent's memory and effectively alter the agent's database such that you can put in optimizations to arrive at results faster. So you probably hear a lot of this stuff that they're called like fine tunes, at least in the OpenAI API, they're called fine tunes. They're effectively, you can train like little augmentations to the model and then apply that augmentation to that model to arrive and specialize in things like the medical field, for example, because chat-gpt is like a general a large language model, so you can specialize it towards certain things that like apply to your use case. So we come to Hey Google, Siri, and Alexa, which my Google just literally went off, and I did not mean to do that. Hopefully no one else is in the room did it either. So the question should be, if we use these autonomous agents inside our digital assistants, like what would that look like? It could get kind of interesting, right? Instead of having it discreetly answer, it could like go and run off for a while and then figure out like more pressing, interesting topics, answers to questions. Like I don't know, for a variety of reasons, like it could be very interesting to see, and we're actually going to demo this a little bit later. It could be interesting to have these things, kind of out there in the environment, such that, you could just ask it to perform certain things, like generate a report. Could be like a long running report. You could have it, generate entire emails and then send them off. So I think these like long running tasks could be a very interesting use case for these kind of devices, right? Like these little edge and IoT devices. And maybe a kind of an interesting side note is because we're using under the covers of these generative AI or these autonomous agents, we're using like large language models, Siri, Google Home, Alexa. If you look at their APIs, they're probably, at least initially, were probably done by just simple parsing of text, extracting tokens. If this token was seen in the sentence, give the weather, right? And it's probably pretty evident based on their API and their API structure. Now, if you take a look at something like OpenAI, they actually have a plugin model where instead of writing code, you say it in English, and that creates your plugin. And that is very cool and interesting, right? It's a whole different way of extending a framework. So I'm trying to race through this because I have some really cool things to show at the end. So IoT Edge, that's kind of like the theme that we're talking about here today. I don't want to take too much time on this, but everyone kind of basically knows like the constraints and design decisions that you need to make when you're talking like IoT edge, right? You're talking usually very little devices, memory constrained, CPU constrained, storage constrained, network constrained. The choice of your hardware or your device is going to vary. It's going to depend a lot on your particular use case. And things like cost is going to come involved, like your use case. The device might need peripherals that you need to suit a specific need. So those things are going to affect like all of your decisions kind of with IoT and edge. But what about constraints for autonomous agents? There's definitely CPU constraints. Like if we're going to try to land like one of these large language models onto a device, there's definitely CPU constraints and limits, right? Because if we're talking about this thing running for a very long time, it's going to eat up a lot of CPU. There's also memory constraints. The larger the language model, like, it might not even fit in the memory for the device, right? So you got to take that into consideration. Even storage limits, right? Even if you can fractionally load, which could be interesting, fractionally load a model into memory, the overall size, you might be limited by the capacity constraints on your hard disk, right? Or memory card or whatever it is. And then the networking, there's always, issues with networking. But when you're running one of these autonomous agents, right, we had talked about that it's running a vector database. So it now has a database sitting potentially on disk. It could be in memory for it to store the results that it's finding for the tasks that make up the larger answer to the question. And then it is continuously performing work. So it's sitting there churning like crazy, trying to figure out the answer to the problem, going out, depending on your device, going out to the internet and doing research or querying like some database that you've provided with like information or knowledge that's specific to your domain or your data set. So yeah, you have all those kinds of limitations. There's probably a ton more, but I think those are the main interesting ones. And so if you have those constraints, like what are possible architectures? I made these drawings a couple weeks ago, but effectively, like one possible architecture is you make your device like you have a lot of CPU, a lot of memory, a lot of disk, and you push everything to the edge. Now, obviously, those devices are going to cost like a lot. So be careful, right? It depends on, like I said, your use case and the things that you're trying to achieve. And then like its call home to some control plane is much lighter weight. Alternatively, you could also have a very, very thin client, so cheaper hardware, but now you're possibly streaming all of that data to the mothership, right? So, and there's also stuff in between. So these are kind of like, use cases or design considerations that you need to take into account, like when you're picking your device and the hardware that you're going to select. So let's try to build one. So I kind of always like to do this. It's a starting point, POC, whatever you want to call it. I created an open source project a while ago. I augmented it within the past couple of weeks. I committed the code, so it is there. So we're going to do a task or context-based assistant. It's written in Golang, so it compiles down to machine code. Because it's in machine code, it's cross-platform. I'm obviously going to run it on my laptop here. So Mac OS, and then because it's machine code, you can compile down to ARM and land it on a device, right? There's two use cases. I'm going to offload all my work, or I'm kind of sensitive to sending my data, and I'm going to run locally. I'm going to run the LLM locally. And I'm going to use Llama 2, which is Meta or Facebook's community-driven large language model, and obviously say in voice and get a response in voice to get the experience like Siri and Alexa, right? So let's do it. No. Yes. Cool. Okay, so the first thing I wanted to show you is I'm going to run Llama 2 on my laptop. And this is literally the command line to do it. I'm going to run it in interactive mode. You can see all the stuff that it is, loading. The Llama 2 model, the 7 billion parameter model is 4 gig, which means you can land it on an edge or IoT device. And you can get a prompt and say, what is the capital of And so you can ask it questions. So now we have a means of asking questions and then getting a response back. Now, I'm going to run BabyAGI, and I'm going for my LLM. I'm using the Llama 2 model that's local on my laptop, so we're air-gapped. I mean, we're air-gapped if I pulled the network cable, but there's other parts of the presentation that I need network, so in this case, we're air-gapped. So if I run this, I've basically instructed the thing to say, hey, create a history of the company Nike, give reasons for its success, and build a report for me. And I basically have kicked it off. Yes, it could be potentially slow. It probably will be, right? Because it's going to churn and it's going to do a lot of work. So it's basically, I'm going to stop it here, but it's basically, you can see that there's a task list at the top. It's going to pull the task off the list, going to process it, and it's going to rinse and repeat all over again until I get a report about Nike, which is very cool. Another thing that's interesting is probably more relevant to us, although you can definitely use the thing like that as is. You can also run it. Oh, shoot, that was my other one. Sorry. More relevant to us, so going back to the Llama 2 model, you can actually, instead of running it in interactive mode, I forgot, you can also run it in batch mode. So what is the capital of California? It's got to load it every time, but you can see that you can get a batched response to running the LLM locally. So LLM, autonomous agent using BabyAGI, and now let's run an assistant, and hopefully I have some time. Oh my gosh. Okay. Hey Kit, create a task called animals. The color of the dog is brown. The color of the frog is green. The color of the cat is white. The color of the bear is black. Hey Kit, what is the color of the cat?
The color of the cat is white.
So I'm muting my mic right here so I can talk. So I did this yesterday. It's basically to prove that it has memory. Hey Crit, Hey Kit, create a task called cities.
The task called cities has been created.
I live in Long Beach, California. I grew up in Mission Viejo. I went to college in Irvine. I want to visit San Diego. Hey Kit, where did I grow up?
You mentioned earlier that you grew up in Mission Viejo, the suburban city in Orange County, California.
Hey Kit, resume the task called animals.
The task called animals has been resumed.
Hey Kit, what is the color of the bear?
The color of the bear is black.
Hey Kit, in what city did I go to college?
I'm sorry, but I don't have access to your personal information.
Because
as an AI assistant, I don't have the ability to know which you went to college unless you provide that information.
Because the context sits in the one with cities, right? Hey Kit, resume the task called cities.
The task called cities has been resumed.
Hey Kit, in what city did I go to college?
You mentioned earlier that you went to college in Irvine, a city located in Orange County, California.
Hey Kit, create a job called Nike.
The job called Nike. What would you like me to do?
Create a report about the history of the company Nike.
Launching long-running job will report back when finished. Create a report about the history of the company Nike. Starting job now.
And that is my demo. So I'm going to bring the slides back up. You can see this, except for the last part. I actually added that last night, by the way. the generative AI part. You can see the video here. The resources for all the links and everything, it's all open source. You can recreate all this yourself. This is how you run Llama 2 on your laptop or device. This is how you run BabyAGI on your laptop or your device. Questions?
how does it distinguish between the facts that you are currently telling it versus there's a context you're building versus the knowledge it already has?
Yeah, so you can use an off-the-shelf LLM, or you can use one that's more specific to like what you need, right? And then you train it based on the data that you're looking to want it to be knowledgeable in. So that's how you gear it towards like what you're specifically looking for. I was just going to use a general conversation LLM, so that's why I picked Llama. If it were something else that's specific to your use case, you pick something else. Like a great resource for that is Hugging Face. They have a whole bunch of models out there that people have contributed that are open source, that are just not, well, that are open to download, may not particularly be open source, but they're geared towards your specific use case.
Okay. Thank you.
If not, I'll be out there for, okay, yeah.
How do you ensure the safety and reliability of
Yeah, you can't, right? Because it hallucinates. So you definitely, I've always said, is AI, question I get all the time, is AI going to replace humans? The answer is no. You need someone to gatekeep the answer and like basically do a BS detector on it, right? You could have in the future a doctor that consults an AI agent, give it all the symptoms, it give you the result, and then the doctor's like, no, that's not right. Like this patient who's sitting in front of me is presenting with more of this. Now go reformulate, and now you may have your true answer. So you still need that person to gatekeep that answer for sure. So